let's talk a little bit about the different components of the vehicle. The powertrain. We do our own in-house powertrain system development. The 21C's engine is an in-house designed twin-turbo V8 within a strong hybrid configuration. There are 2 electric motors up front with torque vectoring that are powered by 2 micro lightweight high-discharge battery packs. Those lightweight compact packs are maintained in a continuous state of charge through a rear generator driven by the V8's crank and through regenerative braking. Our V8 displaces 2.88 liters and uses a flat crank. With the dual turbos set at 1.5 bar boost, about 21 pounds, the V8's output is 950 horsepower at 10,500 RPM with an 11,000 RPM redline. Add in the dual 150 horsepower front wheel electric motors, and the total vehicle horsepower achieved is 1,250 horsepower. Obviously, if you want a performance vehicle that's going to be able to accelerate at the limit, you're going to be limited by tire, by the amount of tire surface with power going through it. The only way really to accelerate the vehicle and achieve the kind of performance that we've achieved is to have an all-wheel drive vehicle, but an all-wheel drive vehicle that's not a heavy vehicle. And that's why we have a strong hybrid where the battery system is relatively small, very compact, and very lightweight, and is recharged through the rear generator on the mid-engine internal combustion engine. The V8 is connected to a 7-speed sequential automated clutch gearbox, also of our own design and packaging. It incorporates a triple plate dry clutch with ceramic metallic friction surfaces and a Salisbury type limited slip differential. Lightweight custom axles are use inboard tripod and outboard CV joints. And of course, in the end, you have to transfer all of that power to the tires and to the road surface. The 21C is designed for maximum grip and handling. From the start, you've seen I've been carrying this in my hand. We've computationally designed and printed ultralight wishbone suspension arms and uprights using our own proprietary alloys. They look biologic not because we were trying to create something that looks biologic, but because when using machine intelligence, going through all of the load cases that are looped in, the durability, thermal, crash, all of the stress, fatigue, and other load cases, which we use high-performance computing to design. This is a front upper control arm. The machine is only taking materials we've designed, and putting it where it's needed. That's the secret of high efficiency manufacturing. Design materials and then put those materials only where the load cases need them, and do it in all 3 dimensions by printing the structure. What that allows you to do is have a much lighter, much more efficient, much stronger structure that meets all of your load cases. And because nature itself is always competing for material and energy, you see structures on this vehicle that look biologic, not because we were trying to make them look that way, but because material, when it goes there to different places where it's needed, is generating those kind of structures. So, in addition to that suspension system, there are driver electronically adjustable hydraulic shock absorbers with active roll control. That enables you to tune compression and rebound settings at each corner of the vehicle. And the suspension system is combined with electronically assisted power steering, adjustable ride height control, and advanced active pitch and ground effect control. For braking, we're using 6-piston caliper front disc brakes and 4-piston caliber rear disc brakes using carbon ceramic discs. So, In total, with a 950 horsepower, 2.88 liter V8, and a total system output of 1,250 horsepower and a less than 1,200 kilogram dry weight for the entire vehicle. The 21C achieves better than a 1-to-1 power to weight ratio and a 330 horsepower per liter power density. That means it's the most power-dense production engine on the planet. It's clear. Our priorities are clear. We're building to maximize power to weight and power density. We look to have the most efficient, most powerful vehicles for every kilogram of weight and every liter of power output. Let's move to how that translates into performance. As I said, we were seeking unparalleled dominant performance. You can claim and achieve amazing isolated performance statistics. All are meaningless, however, unless they come together on the vehicle's playing field. Whether it's Laguna Seca, the Pacific Coast Highway, or Malibu Canyon. You need, if you're going to untap this, you're going to untap the secret of real high performance, you need to create a sum, a synthesis or system of components that achieves performance far greater than simply the sum of its parts.